All right, everyone, we are back and we are on question 2. Everyone loves Kroger-Vink notation. So we're working with this. So this is going to be our host. We want to dope it with an impurity, Fe2O3. So our host can form all these different defects. Activations for anion Frankel is 1. Cation here. So our anion Frankel defects is our dominant defect. But we're going to write out all of the extrinsic defects. So here we have our V is going to be a +7. So just FYI there. All right. So let's get to it. I'm going to do Shocky first. So null goes to a vacancy. Ooh, bad notation, Josh. Professor Steimel. A vacancy in V. Ooh. Oh, I may want to change that. We may change that to like a TA. Vanadium oxide. Oh, no. But we'll work with it. A vacancy in vanadium, that's going to be basically a -3, 4, 5, 6, 7, plus a vacancy in oxygen, which is going to be a +2 here, because 2-. So we're going to do a 2 here and a 7 here. If I'm looking at oxygen, my anion Frankel defect, I'm going to do a vacancy in oxygen plus a oxygen interstitial. If I want to do my vanadium, vacancy in vanadium, which can be 1, 2, 3, 4, 5, 6, 7, plus my vanadium interstitial, which is going to be 1, 2, 3, 4, 5, 6, 7. There we go. Fantastic. We may change that value to X maybe, just to make it a little bit, although that could be confusing too. I could use tantalum. I may just do Ti. We'll see. We'll figure it out. Don't worry. So let's go through here. So we've got all of our intrinsic defects right there. So let's go ahead and let's delete it. Let's go through here. Write out all the intrinsic defects, which defect enthalpy of fusion. A self-interstitial will have a higher enthalpy of fusion because, again, you can relate that to your potential energy. And you can kind of see if I move the same amount of distance here versus here, if I get closer, which would be the case for self-interstitial, you're going to have a higher energy penalty that you have to pay than creating a vacancy. Why crystal will have a finite amount of defects equal in structure. Again, we've talked about that before on our delta G is equal to delta H minus T delta S. So there we go. If we have some concentration of vacancies, it increases our, because we know that our configurational entropy is going to be K natural log number of microstates. If we have some concentration of vacancies, is going to vastly increase my number of microstates. Thus, it's going to increase my entropic term here, which is going to lower my overall energy. Radiodiaphysic reaction that incorporates a cation substitutional. So remember, we're doing our Fe2O3, put that there, into our V2O7. So let's go ahead. Actually, let me erase this quickly just to make it a little bit clearer. Fe2O3 into V2O7. So a substitution will be an Fe where my V must be. So that's +7 to +3. So that's going to be a -4. So 7 + 3. Yep, there we go. So now we want to write a positive defect reaction. So I'm going to do my vacancy in here. I'm going to put 2 of them there. Fantastic. But we're actually a little bit stuck because I need 2 of them. So instead of writing it like this, I want 2 of these. So now I need 4 of this. So that's good so far. What else do I need? So now I'm balanced, right? -8. This is +8. This is -4 times 2. Fe2, now I need 3 oxygens. What about my subscript? V2O7, we're good to go. Fantastic. Let's go ahead. Write a defect reaction that incorporates a cation interstitial. So Fe2O3, goes to V2O7. We have a cation on an interstitial. That's going to be plus 1, 2, 3, 1, 2, 3. I can now actually just rewrite this reaction. 1, 2, 3, 4 minus. And we have a couple of options that we can do here. So now my balance, my mass balance is satisfied here. I could also do plus a vacancy in my host, which is vanadium, which is going to be minus 1, 2, 3, 4, 5, 6, 7. So now this is 7 plus 4. So that's a little bit tricky. So we've got this here. So that's 11. So I can actually do plus vacancy and oxygen 1, 2. I can have 4 of them. And that's going to give me 8 plus 3, 11. I'm good. So Fe, boom, boom. So I've got 2 Fe's. I need now plus 3 oxygen X. I have V here, 2, 7. I'm good to go. And finally, I need a reaction that's an anion interstitial. So I'm going to do Fe2O3, V2O7. I want an anion interstitial, so that's going to be minus 2 here. Plus, let's just do our FeV, minus 1, 2, 3, 4. I'm going to do 2. So that's going to be minus 10, plus my vacancy of oxygen, which I'm going to do 5. Because that'll be plus 10, yeah. And so now I have 2 Fe. I have an oxygen here. I need plus 2 oxygen X. V2 here, nothing here. 5 oxygen here, 7. We're good. That is it. So that is your problem on the exam. So we'll see you next time. Thanks. Well, actually, we'll see you next time in the Solution 3 video. Thanks. Bye.